Well, today's topic is methods of error detection. So mostly we are concerned with the errors in the transmission when the data is being sent from one computer to other computer or one device to the other device. How the receiving device will come to know whether or not the data is correct. The data is in the same form as the sender has sent. So we will use parity check, checksum, echo check and ARQ. So let me explain one by one what is the parity check. So in parity check we will check each byte which is being transmitted from one computer to other computer. Let me make a diagram. Let's say this is one byte. And you know, okay, one byte consists of 8 bits 1, 2, 3, 4, 5, 6, 7, and 8. So these are 8 boxes. So each box represents 1 bit. So when 8 bits combine together, this becomes 1 byte. So before data transmission, both the computers, the sender and the receiver, must agree on the type of parity being used. So there are two types of parity. So one is even and the other is odd. So before data transmission, both the computers, the sender and the receiver, will agree on the type of parity being used. So for instance, the sender and receiver are using even parity and this data is being sent, and you know the bits consist of only zeros and ones. I am randomly entering a number. So one bit is reserved as a parity bit. So this is a parity bit. So we are using at the moment even parity. So number of ones will be counted before the data being transmitted. 1, 2, 3, 4, 5 ones. We are using even parity. So we have a choice to put 0 or 1. Since we are using even parity and the number of ones are odd, so we will put 1 to make them even. So even parity says whenever you are sending the data, number of ones should be even. So this data will be transmitted. So this bit is not the part of data. So the 7 bits consist of the data and the last bit is a parity bit. When this byte is transmitted to any other computer, the other computer will apply this same technique 1, 2, 3, 4, 5, 6, 7 and 8. This is 1 byte that the receiver, this is computer A, it can be any computer anywhere. This is computer B, a receiving computer. For example, during transmission, a few bit, 1 bit or 2 bits get corrupted. Okay. For example, I'm sending 1, 0, 1 and this bit number 4 becomes 0 and the rest of the bits remain same. Now the receiving computer, because both sender and receiver already agreed on the type of parity being used, since they were using even parity, and the receiver was also expecting that the number of ones should be even. So the receiver will again count 1, 2, 3, 4, 5. Now the receiver will come to know we were using even parity, but I am receiving odd number of ones. So there is something wrong with the data transmission. Okay. Now the receiver, the computer B, will send a message back asking computer A to resend this byte. So this time, second time, the byte received was correct instead of 0. Now this time it was 1. The same data that the sender has sent was received by the receiver. So receiver again will count number of bits 1, 2, 3, 4, 5, 6. Now this time the receiver has received even number of ones and the receiver is sure, okay, there is no error in the data transmission. But there is one limitation with this method. For example, two errors occur at the same time, two bits change at the same time. For example, I change these two bits during transmission. These two bits have been changed. So this bit became 0 and this bit became 1. When this data reaches computer B, now the computer B again simply will count number of ones. So it counts 1, 2, 3, 4, 5, 6. The receiving computer will assume that the byte is correct, although there was an error in the byte. But the receiving computer couldn't understand whether there was an error in the byte or not, because there were two errors at the same time. So the even parity has been retained. So this is the weakness, you can say the drawback of the parity check. Now odd parity works in the same way. Now the number of ones should be odd before the data transmission takes place. The sender will make sure that the number of ones are odd. As I already told in the even parity, this last bit has been reserved, okay, for the parity. So we are using odd parity at the moment. Now again count number of ones 1, 2, 3, 4, 5. They are already odd. So the sender will put 0 here because it's already odd, and the sender will keep number of ones odd because sender has a choice of putting 0 or 1 in the parity bit. Okay. Now this byte is sent to computer B. Here 1, 2, 3, 4, 5, 6, 7, 8. 1, 0. The same data has been transmitted and received by computer B. So again computer B is already ready to receive odd number of ones, because now this time they are agreed on odd parity. So 1, 2, 3, 4, 5, the receiving computer will be sure that this byte has been transmitted correctly because number of ones are odd. While checking parity in each byte, though the receiving computer will be able to know whether this byte is correct or not, but the receiving computer will not be able to know actually which bit was corrupted, whether it was first bit, second, third, up to 8th bit. So the receiving computer is unable to know which bit was changed from 1 to 0 or 0 to 1, due to which the byte couldn't reach correctly. So for this purpose, to identify that particular bit, we use parity block. Parity block means now we are not sending individual bytes. Now we are sending group of bytes. For example, in this case, we are sending 9 bytes together. Now the parity will be applied vertically and horizontally as well. So we will apply parity vertically and horizontally. Let's see how. For example, this parity block is following the even parity. So now we will check each byte in turn, starting from byte 1, 1, 2, 3, 4. Number of ones are even. So byte number 1 is correct. 1, 2, 3, 4. That byte is also correct. 1, 2, 3, 4, 5, 6. even number of ones. Byte 3 is also correct. Number 4, 1, 2, 3, 4, even number of ones, since the parity being used is even at the moment. Byte number 4 is also correct. Byte number 5, 1, 2, even number of ones. Byte 5 is also correct. Byte number 6, 1, 2, 3, 4, 5. Yes, byte number 6 has been transmitted incorrectly. So we will highlight this byte, the whole byte. We are going to highlight. Okay, there is something wrong with this byte, because this byte has not been transmitted correctly. Checking byte number 7, 1, 2, 3, 4. Yes, it's correct. 1, 2, correct. 1, 2, 3, 4, correct. So except byte number 6, all the bytes have been transmitted correctly. In the same way, now we will check the column wise parity as well. 1, 2, 3, 4, first column, even, correct. 1, 2, 3, 4, correct. 1, 2, 3, 4, 5, 6, correct. 1, 2, 3, 4, 5, 6, correct. 1, 2, 3, 4, 5, incorrect. So we have selected the column which is not following the even parity. So this column is having a number of ones odd, so we have selected. So keep on checking the other columns as well. 1, 2, 3, 4, correct. 1, 2, 3, 4, correct. 1, 2. So finally we have selected row number 6, that means byte number 6, and the bit number or the column number 5. So both the byte and the column, the bit, intersect at one point. So now we are able to trace out which bit has been transmitted incorrectly. If we change this bit from 1 to 0, now the parity of byte number 6 will be correct. 1, 2, 3, 4, even number of ones, and in the same way column as well. 1, 2, 3, 4. So the whole data block is correct now. So this is how we can trace out, we can actually found which bit was incorrectly transmitted. Next error checking method is echo check. So echo check, how the echo check is applied, how echo check works. For example, we consider this is computer A, as we have considered in other error checking methods. This is computer B, the receiving side. When the sender sends a certain data, let's say this data consists of, okay, my name, Mushtaq. Okay, this data has been sent to computer B, which is a receiving computer. So after receiving this data from computer A, the receiver doesn't do anything except sending this data back to computer A, asking the computer A to compare both the data sets. So the same data has been sent back to computer A. Okay. Now the computer will A compare both the copies which was previously sent and the second which was just received from the computer B. Okay. Now the sender actually compares both the copies. If both the copies are same, the sender is sure, okay, the data received by computer B was correct. If both the copies are different, for example, some data has been missed out during data transmission. So when the receiving computer compare both the copies, they are totally different. So now the sender sends the same data once again to computer B, and computer B does the same thing once again by sending the same data back to computer A. This is echo check. So actually whatever the data being sent by computer A to computer B, B doesn't do anything except sending the same data back to computer A, asking computer A to check both the copies. If both the copies are same, so the data has been received correctly. If both the copies are different, so send this data once again. So this is echo check.